And today we are going to talk about a tricky but super useful topic, that is oxidation numbers. Previously on this channel, talk about balancing chemical equations, okay? And if balancing chemical equation is like playing with Lego blocks, then oxidation numbers are like finding the score for each atom in a compound, okay? So sit back and be attentive as we dive into the class, okay? So first of all, oxidation numbers. What is oxidation numbers? Okay, it shows the total numbers of electrons, okay, that have been removed from or added to an element, so as to get that particular element to its present state. Okay, oxidation numbers talk about the number that is assigned to an atom, okay, so as to indicate its states of oxidations or reduction during a chemical reactions. Okay. What we're saying is that the numbers of electrons an atom can donate or accept to form a bond with another atom. That is oxidation number. Okay. That particular numbers of electrons that an atom can donate or accept in order to form a bond with another atom. That is what oxidation numbers. And of course, with our knowledge of periodic table, we are very much sure that certain elements, because of the group they belong, tells us whether they can donate electrons. Okay. For example, the alkaline metals can donate 1 electron. The alkaline earth metal can donate 2 electrons. Whereas oxygen, okay, we always receive 2 electrons so as to complete the atom shell. Okay. The halogens, we receive 1 electron. Okay. And like that. So the ability to donate and to accept, okay, certain electrons is significant as far as oxidation number is concerned. Okay. Yeah. So if group 1, for example, alkaline metal such as sodium is donating an electron, 1 electron. So it means that it's losing 1 electron. So it's going to become positively charged. Okay. And it means the oxidation number of sodium is going to be +1. Okay. So, well, without wasting much of our time, we are going to talk about the rules. Okay. Let's talk about the rules. I'm going to talk about at least 5 or 6 rules so as to help your understanding of how you can calculate oxidation numbers or how you can find the certain oxidation numbers in a compound. Okay, so let's talk about rules, okay, of finding oxidation numbers. Okay, the rules. So number 1 rules that we will talk about is as simple as saying that the oxidation number of an element in its free state is 0. Okay, the oxidation numbers of certain elements or of elements in their free states usually is 0. So what do we mean by that? If you have elements such as zinc, okay, elements such as aluminum, okay, elements such as chlorine molecules, okay, elements such as hydrogen molecules, okay, these elements, they are all in their free state, and so the oxidation number is going to be equal to 0. So the oxidation numbers will be equivalent to 0 because they are in their free state. Okay, so that's the first thing to take note. That's rule number 1. Okay, so let's talk about rule number 2. So for rule number 2, the oxidation number of a monoatomic ion is the same as the charge on that ion. Okay, so the oxidation number of a monoatomic ion, of course, when we say monoatomic ion, that is the product of an atom that donates 1 electron. Okay, so when an atom donates 1 electron, it becomes a monoatomic ion. Okay, so if you have a monoatomic ions, the oxidation numbers will simply be equal to the number of charge, the same charge on that particular ion. Okay, so for example, if you have sodium ion, okay, sodium ion such as this, for example, so you have sodium ion. So please take note of that. You have your potassium ion, okay, like this. Okay, so the oxidation numbers on them will be equal to +1. Okay, that is equivalent to the number of charge they possess. So this is equivalent to +1. Okay, this is equivalent to +1, and that is equal to their oxidation number. Okay, so this simply tells that, of course, these are alkali metals, group 1 elements. Okay, so wherever you see them, they are going, the oxidation number is +1. So please, let's take note of that. So let's move to rule number 3. So rule number 3 is say that the sum of all oxidation numbers in a neutral compound is 0. What do we mean by that? By the time you summed all oxidation numbers, okay, in a polyatomic ion, that will be equal to the numbers of charge on them. Okay, are we together? So I've stated two things now. Let's talk about them one by one. So the first part of this rule is that when you summed up a neutral compound, okay, when you summed individual oxidation numbers of a neutral compound, what's a compound? Compounds are two or more elements that are chemically bound together, joined together. That is a compound. So let's say you have H2O, okay? So let's have an example shortly. Number 3, if you have your H like this, 2, okay, O, you have your CO2, okay, you have your N, okay, AOH, okay. So these are compound, but of course, they're not just compounds, they are in their neutral, they are neutral compounds. So the oxidation number of this compound being a neutral compound will all be equal to 0 when you sum up individual oxidation number. So for instance, let's say we have we want to find the oxidation number of this, for example. So how do we do that? Let's say we have knowing fully well that oxidation number of hydrogen is +1. So that is +1, okay. Then because the numbers of atoms of hydrogen is 2, so we need to multiply the oxidation number by the numbers of atoms they possess. Okay, then plus, let's say the numbers of atoms of oxygen, okay, is is 1. Of course, the numbers of atoms of oxygen is 1, but the oxidation number of oxygen is -2. You know that oxygen will always receive 2 electrons, okay, and because it's accepting 2 electrons, it's going to be -2. Those giving 2 electrons will be +2, such as in the alkaline earth metal, the group 2 element. So by the time you solve this, this will be equivalent to what? You having +2 times +1 times 2, and that is equal to +2, okay? Then +2 minus 2. So this is equal to 0. Okay, so it goes to all of this. So long as a neutral compound, okay, the oxidation number of that compound will be equal to 0. Are we together? So that is number 3. So let's move to number 4. So for number 4, take note of these rules. The oxidation number of an alkali metal, okay, in a group is +1. Already stated that before, okay. That is alkali metals, elements in group 1, okay, elements in group 1. Please take note of that. So what I mean by that, and the oxidation number of an alkaline earth metal, okay, in a compound is going to be +2. So take note of that. Now let's have example. So if you have something like this, so if you have Na, okay, Cl, okay. So now this rule is saying that so long you can see an alkali metal there, okay, the oxidation number of an alkali metal in a compound is going to be +1. So it means this is +1, okay. Then for the alkali metal there, and then we talk about this. Are we together? So likewise, the oxidation number of an alkaline earth metal in a compound is also +2. So an alkaline metal, let's say you have this, okay, MgO. See that? So now, because I can see magnesium, and magnesium belongs to group 2, okay, and group 2, they are also known as alkaline earth metal. So automatically, this is +2, okay. That means I am going to have something very similar like this. That is +2, okay. This is +2 for this magnesium, then plus that of oxygen, okay. Are we together? Yes. So that is the 4th rule that I want you to understand now. So we move also to the 5th rule. Okay, so the 5th rule, what is it all about? The number of oxygen in a compound is usually -2. Okay, the oxidation number of oxygen in a compound is usually what? -2. But if the oxygen is in a category of compound called peroxides, okay? So the oxidation number will be -1, okay? And if the oxygen is also bounded to fluorine, the number is going to be +1 or +2. It depends. So depending on the compounds, are we together? So what I'm saying is that oxidation number of oxygen, okay, in any compound will always be what? Oxidation number of oxygen in any compound will always be -2, okay? -2, okay? So that is -2. So, but if it is peroxide, so that will not be -2. For peroxide, the oxidation number is what? It is, so for peroxide, okay? So for peroxide, the oxidation number is -1, okay? That is equivalent or equal to -1. So you can have hydrogen peroxide and the like. So the oxygen in such compound will be -1, okay? And not just only in peroxide, I also stated that the oxidation number of oxygen when it's bounded to fluorine, okay, the number is either is +1 or +2, okay? So let's take note of that. So what that entails is that if I have H2O, for example, this is water molecule. So the oxidation number of oxygen in this compound is going to be equivalent to, say, H2, okay, then plus -2, okay? This is it. Yes. So the oxidation number of that is -2. Are we together? Yes. So that is number 5. So, but assuming that we want to talk about the oxidation number of oxygen in hydrogen peroxide, okay, in hydrogen peroxide, that is equal to -1, okay, that will be equal to what? -1. So when you see this H2, okay, H2O2, okay, so the oxidation number of oxygen in this will be equal to something like this. You're going to have H2, okay, like this, then plus your -1. So that's one of the special cases. So take note of that, okay? And also, when we have it with fluorine, of course, it's +2, okay? And or +1, either way. Are we together? Then let's talk about number 6. If the oxidation number of hydrogen in a compound is also usually +1, okay? So let's take note of that. But in the case of a binary metal hydride, the oxidation number is going to be -1, okay? A binary metal hydride such as sodium hydride, okay? So that will be equal to -1. So let's take note of that. So, but aside that, the oxidation number of hydrogen in a compound will usually be equal to +1, okay? So that is, take note of that. So if you have H2O, okay, like this, you have H2O, okay, and then you have your here the oxidation of hydrogen is +1, so you are going to end up having something like this, +1, okay, but because it is having 2 atoms, so you need to now multiply by 2, okay. So but what matters is that it is +1. So let's take note of that. Okay, so without wasting much of our time, the oxidation number of hydrogen in binary metal will be equal to -1. So if you have something like sodium hydride, like I stated earlier, so take note of that. So number 7, the oxidation number of fluorine is always -1. Okay. Also chlorine, bromine, iodine, all of them, they have the oxidation number to be equal to -1. Okay, unless for example, chlorine, bromine, iodine, unless they are bounded to oxygen or fluorine. Okay, so let's take note of that. So what I'm saying now is that for chlorine, okay, for chlorine, that is number 7. Let's talk about number 7 quickly. Okay, so for chlorine, okay, no, chlorine, yeah. So for chlorine, for fluorine, okay, for iodine, okay, for bromine. So all of them, they have their oxidation number to be equal to -1. Are we together? So now, with their special cases, if fluorine, okay, is bounded to a metal, okay, it's still going to be -1. Please take note of that. But if chlorine, bromine, and iodine they are bounded to oxygen and fluorine, that is going to change. It's not going to be -1. So if chlorine is bounded to oxygen, for example, ClO2, let's assume that. So the oxidation number is going to be +4. Okay. Then also, if fluorine is bounded to chlorine, okay, so the oxidation number we also of chlorine there will be +1.